Hello everyone, my name is Tang Guangyi from Hohai University of China. It's my pleasure to share our research. The topic of the presentation is an improved ViBe-based approach for moving object detection. The contents include background significance, research methods, results, and summarize. The real-time detection of moving objects is an essential task in the computer vision field, which has wide applications, including target tracking, video surveillance, abnormal behavior analysis, intelligent robot. There are some challenges, such as illumination changes, swing lifts, and shadow changes. The method can be divided into three main types: the optical flow method, the deep learning method, and the difference method. There are some difficulties in real time handling ghost areas and shadow removal. Our research method includes mode background modeling, adaptive updating mechanism, and shadow removal strategy. First is the mode background modeling. The initial background selection is the first step in the ViBe-based method. In general, the ViBe method uses the first frame as the initial background. The basic idea is that few previous frames are used to obtain background model. The pixel value is calculated by this equation. When the sample size of all the pixels in the background are obtained, a background model is set up. The second is adaptive updating mechanism. We use this equation to judge the pixel of the new frame as the background or foreground. The following step is to randomly update the background model with each new frame. In general, the detection radius should be larger and the update rate should be smaller, because the value of the 8 neighboring pixels, difference between the background and the current frame, is the factor that can reflect the complex degree of background. With this method, the ghost area disappears quickly. The last step is the shadow removal strategy. We use the HSV color space. The main reason for using the HSV color space is that it is very close to the characteristics of human vision. The basic idea is that the shadow area can be effectively distinguished by using the characteristics of shadow intensity reduction and color invariance theory. For any pixel point, the brightness value between the current frame and the background frame is used to determine whether the current pixel is a shadow point. The decision strategy is determined by the following equation. For each shadow pixel, its darkness level is limited, and the shadow pixels are mostly in gray areas. By this equation, the shadow areas can be removed. To test the efficiency of the proposed approach, it was compared with the GMM method and the general ViBe method. The detection results on work show that the general ViBe cannot deal with the ghost problem. The detection results on bundles show that the proposed ViBe can remove the shadow more effectively than the other two methods. In the experiment of multiple object detection, the proposed method can efficiently process ghost area. In the 4D side, the background is changing obviously because of the leaves shaking. In the bold D side, the video is blurry due to the shake of the camera. The results in the two experiments show that the performance of all the three methods decrease. However, the performance of the proposed approach does not decrease dramatically compared with the other two methods. Another important index of the moving object detection method is the real-time problem. The results in this table show that more time for the object detection is needed using ViBe than the GMM method, because the GMM method selects the initial background frame randomly. In addition, more time is needed in the ViBe-based approach during the background modeling process, which can be offline processed. In this paper, the proposed approach can deal with moving objects efficiently in various situations. In future work, some more efficient methods based on artificial intelligence algorithms should be studied to improve the accuracy and real-time ability for moving object detection. That's all. Thank you for listening.